So we had here like, okay, substitution rule. Now we can just take this half on the left side, right? So we get half integration of cosec x square t dt. So we have to substitute back the value of t, that is 2x. So ultimately, the answer is minus 1 by 2 cot 2x plus c, okay? Guys, can you understand? Hello?
Yes.
Okay, so let's go to the next question. Number 5. Oh no, we have something more. Yeah, so the answer is minus half cot x plus c. Minus half cot x plus c. So number B, right? Sorry, number D. Minus half cot x plus c. Okay, I'm again sorry. So the answer is minus half cot 2x plus c. So number D. Okay, minus half cot 2x plus c. Number 5, the following calculation procedure dash is not appropriate according to the integration by parts. So integration by parts, the formula is integration of u dv is equal to u multiply v minus integration of v du, right? So how to find dv? So to find dv, we have to first we need to let u. So here we know the order. So I just remember this way that I love pet. I love my pet. Okay. So I means inverse trig function. Love means log function. T means power function. E means expo function, and T means trig function. Okay, Alamin, Stuti.
I'm literally hanging.
Okay, no problem. So, Stuti, do you understand this? Like, this is the order, okay? So here we have trig function and we have expo function, right? Sorry, we have power function and we have trig function. So we know that our order is, this one is first. Inverse function, it is our first choice. So the power function we have at the third position, right? And fourth position we have expo function, and fifth position we have trig function. So we have to substitute x is equal to u. We have to substitute x is equal to u, okay? Because this is our order, okay? So if x is equal to u, then cos x, I have to convert this cos x is into dv. Okay, so to convert it to dv, we have to find the integration of cos x, the integral of cos x. So integral of cos x is sin x. So we write down this way: integration of x d sin x. So this one is correct, but we have to find which calculation procedure is not appropriate, right? So we have to find the wrong procedure. Number B, integration of x e to the power x, integration of x e to the power x dx. So again we have power function here and we have expo function here, right? So we know that power function is at the top, is power function is before the expo function, right? Okay, let me drink some water. So power function is before the expo function. So here x is equal u, okay? So here x is equal to u. So we have to convert this e to the power x to something like dv. So to convert e to the power x to dv, we have to find the integration. We have to find the integral value of e to the power x. So integral value of e to the power x, it is also e to the power x. Okay. Guys, do you remember the formula? You see here, integration of e to the power x dx, it is e to the power x plus c, right? So that's why I write here e to the power x. Okay. So this one is also correct. And number c, we have integration of x cos x dx. So it is written half integration of cos x dx squared. So if I just let x is equal to u, if I let x is equal to u, then cos x, I have to find the integral of cos x. So integral of cos x, it will be sin x, right? So in here they had to write sin x, but they have written here cos dx square. That means this one is not correct. And number d, we have integration of e to the power x cos x dx. So if I take so how will be the order? This is expo function and this is take function. So we can just take either expo function or take function. Okay, we can let either expo function as u or take function as u. So for example, here we let expo function as u. Sorry, we let cos take function as u. So now if I just take this if I just compare it with dv, so integration of e to the power x, it will be also e to the power x, right? So here cos x is equal u, and e to the power x, we have to convert it to something like dv. So to convert it to dv, we have to find the integration of e to the power x. So integration of e to the power x is also e to the power x. So ultimately the answer is integration of cos x d e to the power x. So this one is also correct. That means number C, it is our answer. Guys, can you understand? Stuti, Alamin is on the way.
Yes. I can understand it.
You can't understand? Okay, let me explain again, okay?
No, I understood it.
Okay, fine. My health condition is not okay, like from yesterday. That's why I'm having some problems. So number 6. Ah, Number 6, we have the value of the integration of -1 to 1 plus sin x by 1 plus x square dx is hot. So you see here we have some it is called symmetric interval, right? So we have some kind of symmetric interval here. Where is he? Pause. So as we have some kind of symmetric function here, so symmetric function means integration of minus a to a, okay? Some kind of function like this, integration of minus a to a. So integration of minus 1 to 1 on plus sin x by 1 plus x squared dx. We have to think we have to think of even function and odd function, okay? To solve this, we have to think of even function and odd function. So you can see here. Maybe. So here, okay. If f of minus x is equal to minus f of x, if f of minus x is equal to minus f of x, then it will be a odd function. And for odd function, our formula is integration of minus a to a f of x dx is equal to 0, okay? So for odd function, the value is 0. And about even function, if f of minus x is equal to f of x, then integration of minus a to a f of x dx, it will be 2 into integration of 0 to a 2 into integration of 0 to a f of x dx, okay? So this is like odd function and even function formula. So we have to put some value here, like we have to put minus x here, and we have to see we have to see if it is a even function or odd function. So I put here minus x. So on plus sine minus x divided by on minus x square, that means plus x square, okay? So on plus sine on plus, so it will be on minus sine x, okay? Or we can write down like minus sine x. So we are not thinking about this one. We are not thinking about this one, okay? We have to think of this sine x by 1 plus x square. So if I just input minus x instead of x, so it will make something like minus sine x by 1 plus x square. So you see here, we had g of x is equal to sine x by 1 plus x square. So this is a symmetric integral, okay? So we have to find g of minus x. So g of minus x is minus g of x, okay? Because sine minus x we can write down like minus sine x, and on minus x square we can write down like 1 plus x square. So this part sine x by 1 plus x square, this part is g of x, okay? So we can write down this part is g of x, and this minus is here. So ultimately the answer is minus g of x, okay? So as it is minus g of x, so we can say that it's a odd function. So for odd function, we know that their value is 0, right? So instead of all these things, we can write down 0, okay? And now let's let's calculate this part. Integration of minus 1 to 1. Integration of minus 1 to 1 on dx. So this part we can calculate this way, like so integration of on. So we have to find the integration of on. So integration of any constant. Integration of any constant value, it is x, okay? It is x plus c. So we don't consider c, we just consider x. So this is x, and we have to plug in the limit. So limit, it was minus 1 to minus 1 to 1, right? So minus 1 to 1. And now if you calculate this part, it will be FB minus FA. That means we have to plug in the value, like if I plug in firstly we have to plug in upper limit. So it is 1, and then minus we have to plug in the lower limit. It is minus 1. So ultimately the answer is 1 plus 1. 1 plus 1 is 2. Okay. So our answer is number 6. So answer is C. Okay. And number 7. At the point x equal to 0, the function f of x equal to modulus x is dash. Is it continuous and differentiable? Is it neither continuous nor differentiable, continuous but not differentiable, or differentiable but not continuous? So if left hand limit is equal to right hand limit, is equal to our function value, then this function is continuous. And if differentiable, that means so if its derivative exists, and if it is continuous at a specific point, and if their derivative value, okay.
Hmm.
So what is the point here? The point is x equal to 0, right? The point is x equal to
Yes.
0. So you have to see if this function is differentiable at x equal to 0 or not. Okay.
Okay.
So let's see here. But this step is not so clear because maybe some mistake here. Lassi did it in here.
Oh no.
Again, oh no. What a shanti buthai how.
A male?
Male. Hmm. Lecture 3. Where am I going? No. I have to see lecture 3.
I don't know what I'm going to do in the exam.
We are going to get 100 out of 100.
Yeah, we know. We all know how.
Allah. You can see here.
Yeah.
So f of x is modulus x. Oh, it's very big.
There's a pen going on.
F of x is modulus x. Is this function continuous at x equal to 0? So for f of x is equal to modulus x, we know that it will be plus x and also minus x, right? So this is our right hand limit, and this is our left hand limit. So now we have to calculate our left hand limit and right hand limit. So right hand limit, that is, it is positive, right? So limit x tends to 0 plus.
Mm.
So if I draw the graph, it is like a function that is coming from plus, okay, from plus to 0. So this means this part, limit x tends to 0 plus modulus x. So it will be plus x, right? We can see here our right hand limit. It is plus x. So we can write down this way. The next line will be limit x tends to 0 plus limit x tends to 0 plus x. So now we have to substitute the limit. If we substitute 0 here, it will become 0, okay? If
Yeah.
the value of x is equal to 0, if the value of x is equal to 0, so ultimately all this value is also 0, okay? And now from
Okay.
now about the left hand limit. So this is our left hand limit, okay? So this is our this is the function for left hand limit. So if limit x, if x approach to 0 from the left side, so modulus x, it will be minus x. And if I again substitute 0 here, so minus 0 is equal to 0, right?
Yeah, yeah.
So now we have to find the, we can see that our left hand limit and right hand limit, they are similar, okay? And now we have to find
Okay.
the function value. So to find the function value, we have to see where where x is equal to what, okay? You see here x is equal to x is greater than or equal to 0. That means x equal to 0 exists here. So we have to take this function. So f of this function, that means f of x is equal to x. So now if we substitute, if we want to find f of 0, so it will be also 0, okay? Just substitute back 0 here. So it will be 0, okay? So we can see that our left hand limit,
Okay.
our right hand limit, and our function value, they are same, right? They are similar. So that's why this function is continuous. And if it is differentiable or not, we have to see if it is smooth or not, okay? If this function is smooth, then it is differentiable. And if this function is not smooth, then it is not differentiable. For example, if we want to graph this function, it will be like this way. So you see here, there is a corner, right? So this function is not smooth. This function is not smooth. That's why this function
Yeah,
is
yeah.
not differentiable. Okay.
Okay, okay.
So you see here, a differentiable function
I see.
should be always smooth. A differentiable function should be always smooth. But here is some corner, so it is not differentiable.
Yeah, I see.
Okay.
Hmm. It's a really
Derivative of modulus x. 1. Okay, so let's go to the next question. So this function is continuous but not differentiable, okay? So the correct answer is C. So part 3, we have to calculate, we have calculation problem. So 49 marks, okay? So for part 1 and part 2, we
nice.
don't need to write down any steps. We just need to tick. We just need to write down the correct answer. But from for part 3 and part 4, we also have to write down the procedure. So find the limit of limit x tends to 1, x minus 1 by root over x plus 3 minus 2. So let's see if we can directly plug in the value or not. So if I like write here 1, so 1 minus 1 divided by root over 1 plus 3. It is very long root over 1 plus 3 minus 2. So 1 minus 1, that means 0, and 1 plus 3, that means 4. So root over 4 is 2. So 2 minus 2, this is also 0, right? So we get something like 0 by 0.
Yeah.
That's why we have to think some other way. So here I just multiply using their conjugate, okay? That means the opposite sign. You see here is minus, but I multiply using plus, okay? So I multiply the conjugate on upside and downside. So here conjugate is root over x plus 3 plus 2, okay? Root over x plus 3 plus 2. So what is the benefit of this? So the benefit is if we multiply the conjugate, so it will make a plus b into a minus b. That means a square minus b square, okay? So a square minus b square means x plus 3 a square. That means root over x plus 3 whole square. A square minus b square, okay? So so we can cancel the root and square, okay? We can cancel the root and square.
Okay.
And 2 square, that will make 4. So x minus x plus 3 minus 4. That means x minus 1, okay? X minus 1. So this is the answer. This is the answer of down part. And upper part, we can also cancel this x minus 1, right? So we get a single line. So here is the benefit of multiplying using the conjugate. Okay, Alamin? Bro, you see here we can cancel x minus 1, x minus 1. So we get a single line, and that was our target. It is the benefit of multiplying using the conjugate, okay? So now we can just substitute back, you can just plug in a value here. So root over, if I plug in 1 here, so 1 plus 3, that is 4. So root over 4 is 2. So 2 plus 2 is 4, okay? Alamin, am I right? Hello? Alamin, I can't hear you. I can't hear you. Hello? Yeah, rejoin. So can you understand number 3? Sorry, number one of part 3. Hello.
Now I think.
Okay, thank you. Number 2. So number 2, we have y is equal to x square e to the power x plus sin x by x minus ln 2. Then find dy by dx as a function of x. So we have to find dy by dx here, okay? So very big function. So we have to say, we can just use sum rule here, okay? Sum rule means firstly we have to differentiate this function plus this function and plus this function, okay? So let's calculate
Yeah.
one by one. So dy by dx is equal to ddx of x square e to the power x plus ddx of sin x by x and minus ddx of ln 2, okay? X squared by e to the power x, sin x by x and minus ln 2, okay? We just differentiate, we just use sum rule, okay? No problem, just sum rule. So now this is something like multiplied, this is like product rule. So here is x squared into e to the power x. Hello Michelle.
Hello, how are you?
So I think you joined like 2 hours ago and you just went back. So I couldn't find you.
Yeah, I was having a network problem. Sorry.
Okay, so no problem. So here we have come up to here. Part 3, the second question. So the question is, suppose y is equal to x squared e to the power x plus sin x by x minus ln 2. We have to find dy by dx. So we can first use sum rule here, okay? And we can calculate them one by one, okay? So ddx of x squared to the power x, ddx of sin x by x minus ddx of ln 2. So this is like a product rule, x squared into e to the power x. And we know that product rule is u v derivative is equal to u derivative v plus u v derivative. Do you remember? Hello, Michelle.
Yes, sorry, I can hear you.
Okay, so you remember the product rule?
Yeah, I do.
Okay. So u derivative v, that means derivative of x squared, it will be 2x and multiply v plus v derivative u. So derivative of e to the power x, it is e to the power x and u is x squared. So here we used product rule. And ddx of sin x by x minus ddx of ln 2, this is something like this is like u by v, okay? This is a divide rule. So u by v derivative is u derivative b minus u v derivative by v squared. Do you still remember?
Yes, I do.
So here we have minus. So we can just write down this way. U by v. So u derivative v and v derivative u. Sorry, not this this part, okay? ddx of sin x by x. We can write down this way. Like this is u by v. Sin x is u. Sin x is u. And x is v, okay? So u by v. So u by v is u derivative v. That means derivative of sin x is cos x. And here v is x minus of the formula. And derivative of b is only one, right? Derivative of x will be one, and then multiply u. And on the round side we have v squared, that means x squared. So this is the answer is x cos x minus sin x by x squared. And here we have ln 2. So we know that derivative of ln any constant, that will be 0, right? So we can just write down plus 0 here, or we don't need to write. So ultimately this is the answer. So let's see number 3. Michelle, do you understand number 2?
Yes, I do.
Okay, so we have only 1 minute, 2 minutes left for our meeting. So we will join again. Okay, the same ID.
Okay.
So number 3, we have to find limit x tends to 0 e to the power x minus cos x by x. So we can just think of. So can we input this value here? If we input, if we just plug in the value x equal to 0, then we get e to the power 0 minus cos 0 divided by 0. So you see here e to the power 0, that means 1, and cos 0, that means that means also 1. And down here we have 0. So 1 minus 1, that is 0. So we get something like 0 by 0. That's why we have to think another way, right? That's why we have to think another way. So look here. We have a 0 by 0 format. So we have to use L'Hopital's rule. That means upside derivative and downside derivative rule, okay? We have to find the derivative of both upside and downside. So derivative of our numerator, this will be e to the power x minus cos x derivative. That means derivative of e to the power x, it is e to the power x, and derivative of cos x, it is